We'll talk today about maximums and minimums. Okay. So what do we know is true at a minimum?
The slope is 0.
Okay, the slope is 0. Okay, and that is what I taught you, all right? That's what I taught you. But there's also another case, and that is the slope is undefined. All right, so let's look at y is equal to the absolute value of x. Looks like this. As you approach 0 from the right, what is the slope? As you're approaching 0 from the right, what is the slope? What is the slope of that?
Positive.
Positive what? Really? You can't tell me the
1.
slope of y equals the absolute value of x on this
1.
side. Can you take a shot at it? I'm looking for a number.
1.
1. Slope equal 1. On this side slope is equal to what?
From, where are you coming from?
From here on this side.
Negative 1.
Negative 1. So as I'm approaching here on this side, the slope is 1. From this side, the slope is negative 1. At that point, what is the slope?
Undefined.
Undefined. Okay, it's undefined. But is that a minimum? Is that a minimum?
Yes.
Is the slope 0?
No.
No. So, at a minimum, the slope is either 0 or it's undefined. Okay, and what you got to see is used to, you would think about like, you know, this being something strange, like there's something strange going on there, right? Okay, but what you have to see is this is continuous, right? If you look at this, this is continuous, but something strange is happening with the slope. The slope is not continuous because the slope would be like here, and then the slope would be here, and the slope is undefined there. All right, so the derivative is 0 or undefined at an extrema. Now this would be kind of like an absolute, and we call a minimum, a maximum or a minimum, we call them extrema. Okay, we call them extrema. And so at a maximum or a minimum, the extrema, you're going to have a slope of 0 or the slope is going to be undefined. What is true, what could you say also about that point? What kind of minimum is it? Okay, what would be the difference between that and?
That would be a relative.
Yeah, this would be a relative minimum. I mean, you said it,
Yeah,
right? This is a
relative.
relative
That's an absolute.
minimum. This is an absolute minimum. And this relative minimum is also called a local minimum. A local minimum. Like I have the smallest house in my neighborhood, it's not the smallest house in the world. Okay. A local minimum is what it is sometimes called. All right. So let's say I tell you to find the local extrema of y equal 2x cubed plus 3x squared minus 12x plus 5. Anthony, if I told you to find the local extrema of that, what would you do?
Without graphing?
Yeah, without graphing.
Set f of x equal to
No. That would find the zeros. I want to find the extrema, right? So like
Find
if
the
you look at
derivative.
if you look at that, those are not extrema. You
Find
would
the derivative.
take the derivative, okay? So I'm going to say y prime is equal to what?
6x squared plus 6x minus 12.
Okay. And then what I could do is I could set the derivative to 0, okay? And then I have 6x squared minus 6x minus 12. What would you do now?
Go plus 6x there.
You would what?
Plus 6x. Made it a minus. There you go.
Okay. I'd factor out a 6. Divide both sides by 6 and I have x squared plus x minus 2. Right? Did I do that right? I think I did that right. Okay. And then that is going to be x. Can I do that? X plus 2 x minus 1, right? X squared plus 2, okay. And then I've got an extrema at x equal negative 2 and at x equal 1. Okay, I know they're extrema, but you know, I'd have to kind of graph it probably to see if they're, I have to graph it to see. Okay, let's do another one. F of x is equal to 3x plus 1 to the 2/3. Okay. If I want to find the local extrema, what would I do?
Take the derivative.
Okay. So that's going to be equal to 2/3.
3x plus 1 onto negative 1/3. And then you have to take the derivative inside times 3. Yeah.
So this would be equal to 2 over the cube root of 3x plus 1. Now, if I set that to 0, where is the extrema? Or tell me something about the extrema. So say something out loud. Anthony, say something out loud.
You would have to multiply out the denominator, which would be 0 times that.
So then, at what x value do you have a minimum? I wouldn't say it is undefined. I would say that it doesn't have a minimum because it's going to get smaller and smaller and smaller as what happens?
As your x value grows.
Yeah, as x gets bigger and bigger and bigger. But is there any way that I could make this term go to 0? No, there's no x that will go to 0. As x approaches infinity, it approaches 0. So what you have is you have something that would look like that. Okay, so that never gets to 0, so you never have a value that's a minimum. Does that make sense?
Mhm.
Okay. So what you can see is that the slope is never going to go to 0, so you don't have a minimum. Okay, sometimes what you have to also be careful about is why you usually want to graph these things as well. Sometimes f prime of x equals 0, and there is not an extrema. Okay? So let's think of y is equal to x cubed. And I asked you to find a minimum or